Today we're going to look at arithmetic sequences. Now, arithmetic sequences are sequences each term has a common difference between consecutive terms. So, for instance, let's say I gave you 5, 9, 13, 17, 21. You can see my pattern is that I keep adding on 4, adding on 4, adding on 4, adding on 4, or that the common difference, 9 minus 5 is 4, 13 minus 9 is 4. The common difference is 4. Now, they don't necessarily have to go up by 4. I could have a sequence that goes down by 4 as well. So I could start with 4 and have a term of 1 and have a term of negative 3 and have a term of negative 7 and have 1 minus 5 is negative 4. Negative 3 minus 1 is negative 4. And in this case, I would say that my common difference is negative 4. So when we're finding the common difference, it's always the second term minus the first, the third term minus the second term, etc. And so if I have my terms of my sequence, what we want to end up doing is having some type of an explicit and recursive rule that will help us describe what happens. And with arithmetic sequences, they're actually very easy. There's a pattern that is the same for all of the terms. So I have an example. Here are my first term, second term, third term of my sequence. And if it's arithmetic, you know obviously the first term is the first term. To get to the second term, we actually take the first term and add on d. And then if there's a common difference, once again, we could take the second term and add on d, and that would find our third term. The next term would be take the first term, or this previous term, and then add on d again, which means that's going to become 3d. So I keep adding on an additional d. Next term would be a sub 1 plus 4d, etc. So if we want to write an explicit rule for this, arithmetic sequences are actually, as I said before, very easy to write the pattern. Explicitly, and I'll do it with my number example that I had the 5, 9, the 13, the 17, the 21. If I want to find ... this nth term, I think, all right, I want to find a sub n, and I know I have to start with 5, and then I know when I keep adding on this common difference, and that common difference in my case is 4. And to get from the first term to the, let's go, second, third, fourth, fifth term, notice that I have to add on 4, 1, 2, 3, 4 times. To get to the sixth term, I would have to add on 4, 1, 2, 3, 4, 5 times. So this common difference, I'm always adding on n minus 1 times. So for this particular sequence, I have my first term. I keep adding on the common difference, and I would do it n minus 1 times to get to the nth term. So here's an explicit generalization for an arithmetic sequence. So if we want to find the 80th term, plop 80 right there, 80 right there. Got to know your first term, got to know your common difference. Now for the recursive rule, I'll write the recursive rule for this one, and then we'll look at that value. So if I want to write a recursive rule, I always have to tell someone where to start. And then I have to tell them how to find all the terms after that. And we know that once you know this term, all I have to do is add on, in my case, 4 to get to the next term. If I have the fifth term and I want to find the sixth term, I just need to know this term and add on 4. So I need to know the term who's right in front of him, who is a sub n minus 1. Make sure that subscript is low. And I need to add on the common difference. Now technically, we're supposed to write and let people know that this n is for n that is greater than or equal to 2, and n is a member of the integers. I'll let you leave that part off. We'll kind of understand that that little part is there. So in general, for any arithmetic sequence, you have to tell someone what the first term is. You always have to tell them where to start. after that, they can recursively find the rule by taking the term in front and the a sub n minus 1, add on the common difference, and that will always give you the a sub n. Now, next question. If I look at this pattern, we can see that it appears as though I keep adding on 3, or the common difference between consecutive terms is 3. So yes, this is arithmetic. Now, you try to write what the recursive and explicit formulas are for this, and then I will move the paper. So you could stop the video, and then I'll show you what you should have. Okay, this is what we should have. The explicit rule, I want to find the nth term. The explicit rule, I don't have to know a previous term. I just look at this one rule, and I plug in whatever term I want to find. I want to find the 6th term. I can plug 6 right in here and right in there, and I'll have my 6th term. My first term plus the common difference times n minus 1. Recursively, you always, in a recursive formula, have to start out and let someone know where they're going to start. And once you tell them where to start, this second part of the rule will always tell you how to find all the terms after that using the term in front of it. So to find the nth term, I take the term who's right in front, who is a sub n minus 1, and add on 3. Now I have a little diagram that shows a sequence of dots. And I counted how many were here. And we can see what the pattern is. But we can see that you add on 3, add on 4, add on 5. So there's obviously a pattern. But because this common difference is not the same each time, it's not considered an arithmetic sequence. It is a sequence. We could actually find a rule for it. It would end up having to have a square term in it, actually. But it's not too hard, really, to write the recursive pattern. Because once you know this, you know you're going to add on 3. So if this is the first term, is 3. The second term, I add on 3 to get to the second term. To get to the third term, I add on 4. To get to the fourth term, I add on 5. So I can see each time I keep adding on to find the fourth term, I had to add on one number higher than the position I was finding. So I have to tell you where to start, and then I can actually recursively generate this. And you could use this formula and verify that you actually will get that. Now, sometimes we'll have some application questions, and we have to be careful about the wording of the question and read it. And once you think you got it, read it again. Suppose you've already saved $75 toward the purchase of a new CD player and speakers. You plan to save at least $12 from money you earn from a part-time job. In all, what is the minimum amount you could have saved after 26 weeks? And so if we kind of look at the pattern, we know after the first week you have $75. Then you plan to save 12, so the next week you'll have at least this much money. And then the next week you'll have at least this much money. And notice that I want to go after 26 weeks. And this is when you had $75 at the beginning, and you actually want to find the 27th term, not the 26th term, because this a sub second term is actually after 1 week. So I want to find the 27th term, and notice it's in the arithmetic pattern. I start with 75, and I keep adding on 12 each time, so my common difference is 12. So if I want to find the 27th position, which will be after 26 weeks, I start with $75, I add on the common difference. I will have added on 12 26 times, end up with $387. Flip the page. Want to find the 9th term of the sequence. Always look at the sequence and see if you see what the pattern. Looks like I'm adding on 3, adding on 3, adding on 3. It is arithmetic. I'm adding on 3 each time. And I actually know how to find both an explicit and a recursive rule. If I were going to find an explicit rule, I would say start with the first number, and you can find any position after that by taking the common difference times n minus 1. If I were going to find a recursive rule, you always have to tell someone where to start, and then you can find any term after that by taking the number who's right in front, and we have to add on 3. However, we want to find the ninth term, and I don't want to do it recursively because that means I just have to keep adding on 3, adding on 3, adding on 3. We're just going to use this explicit rule. And so we want to find the ninth term. Start with 2, add on 3 8 times. Now sometimes we have to do a little bit of algebra, and be careful of the way the question's worded. 344 is a term in this arithmetic sequence. And notice I go up by 7, up by 7, up by 7. So my common difference is 7. And we want to find the position of this term. So somewhere down the road here, there's a number who is 344. This is the first term, second term, third term, fourth term. I want to know what term that is. Well, I know I start with 8, and I keep adding on 7, and I need to do that n minus 1 times, and I'll finally end up with 344. And then you do the algebra. And I find out that it was the 49th term. Now, another concept that we look at is an arithmetic mean. And you know what an arithmetic mean is. Arithmetic mean is what you get when you, quote, find the average. Add them together and divide by 2. So if I gave you a list of numbers like this, I could ask you to find the arithmetic mean or figure out what this number is in the sequence. Add them together and divide by 2, and you'll get what the arithmetic mean is. So it's the number that's halfway between. Notice if I plop 71 there, if I add on 21, I get to this number. And if I add on 21, I get to this number. So it's the number that fits the pattern. Actually, if you had graphed this, it's the one that is right in between linearly. Now, we can have terms, though, that have a little more oomph to them. And yours are blanks here. So mine's already figured out, but I gave you 14, and I have 1, 2, 3, 4 blanks, 1, 2, 3, 4 blanks, and then I give you this last term. And I say, it's arithmetic sequence, and I'm going to tell you what the first term is, and I'm telling you what the sixth term is. And I want you to fill in the blanks. Well, I have a little situation here that I can't just figure out what these numbers are in between without analyzing it based on my explicit rule for finding an arithmetic sequence. I know that you find an nth term by taking 14 and adding on some common difference, n minus 1. Now, I know what the sixth term is. So I know that if you plug 6 into here, and are looking at the a sub 6th term, you're going to end up with 15.6. Ha-ha! The only thing that I have unknown is my d. So I can do the algebra and solve and find out what my d component is. And I know that's what my common difference is, so I can keep adding on 0.32 to get to the next term. So we have a number of different ways that we can figure out some different blanks. But this is probably the best way to use as a generalization. Your book will show you a couple other things to do that only work in specific type of questions. This type of technique, regardless of how many blanks are in here, is going to work for every problem. So that's what I'm going to show you guys. So now you're ready to practice.